Okay, I think I'm live. Just to make sure everything's working, can someone just ping me a message to say that they can hear me? Anyone? No dramas. I think just going to wait for a few more people to drop in. And then I'm going to crack on. Wicked. All right. I think I'm going to start. Okay. Well, firstly, welcome to another Earth Live lesson. And thanks to Lizzie Daly for setting these up. I think it's a great way for people at home to get a little bit of science in their day to day. My name's James Redcliffe. I'm a PhD student at Swansea University. I work in the Animal Movement Lab. It's actually called the Swansea Lab of Animal Movement, or SLAM is the acronym. And it's a really great place to work because we use all this great technology, which I'll explain a little bit later. But I also get to work with some fantastic people. So first and foremost, I work with Professor Rory Wilson, who is really great in the sense, and also I think he had a video that did the rounds on the BBC where he was constantly getting interrupted by a penguin, and it was fairly amusing. Penguins are like his thing. I think that's a little bit of an understatement. And yeah, so, and then I work with my supervisor, Professor Luca Borga. He doesn't necessarily have an animal that's his favorite, but I think he spends a lot of time on deer, and I think he's got a soft spot for porcupine, which I think he did his PhD on. I work with Professor Emily Shepherd. She studies like the mechanics of flight. She's a massive birder. And we also have Dr. Mark Holton, who helped design the tags and also has built this software to visualize the massive amount of data we get from our little tags. So that's the lab. Let's break into the actual tech itself. So we deploy remote devices called daily diaries onto animals. And so you put them on via a collar or some glue or sticky tape, or some really, not just sticky tape, really, really strong tape. And we can collect pieces of data about the actual animal itself and external environments. And I've actually got one here to show you. Just get it out of the bag. So it's quite small. And let me try and show the camera to you. So yeah, it's a really small circuit board, just bigger than a thumbnail. It's got different processors and sensors on it, just a simple circuit board. And those sensors collect a number of pieces of information. The main one, which I'll talk about in a little bit of detail, is acceleration. Now, acceleration is the rate of change of speed, but this isn't like speed, acceleration or speed in a car. This acceleration is measured in G. So I can then use this as a bit of a tool to try and give you an idea why that can be useful. So if we imagine acceleration is being measured, and this is a chronological or time-based plot. So as time goes along, acceleration is measured. And as acceleration changes, it can produce a signal, like, I don't know, like a seismic graph you get for earthquakes. And that signal can be really similar or have a pattern associated with a behavior. So to try and make it a bit more simple, in other terms, we can understand what the animal is doing when we can't actually observe it. These devices collect that data for us. The other things these devices collect are magnetometer data, so we can get an idea of what direction the animal is facing based off of its position relative to the globe, like a compass. And they also record temperature and pressure. Pressure can be really cool for aquatic or marine species when they're diving underneath. We can understand what depths they might be reaching and at what time. And also, pressure can be used to calculate altitude, so we can work out what height birds might be flying at. And And our lab has tagged a range of animals from quick moving cheetahs to massive elephants, and also really tackled some trickier species to tag, such as loads of penguins, as you can imagine. And we have a few sharks, small birds in the sky like pigeons, and larger birds like condor. But when I first got to Swansea, I kind of had this vision in my head that tagging would be like a spy movie or James Bond, where you get this tiny, tiny device, you'd swallow it or something, or be able to put it on the animal with not many repercussions, and you'd be able to find out where that animal is at any time, no problems at all. But the reality isn't the same. And a big issue is weight and battery life. So I think a good way of trying to make you understand is a phone. A phone, it does a lot of things that we want our devices or accelerometers or daily diaries to do. They record magnetometry, they record location using GPS, that's how you use your maps. They use accelerometry as well to give you an understanding of how many steps you've taken. But the thing is with a phone is you charge it either every day or every other day. And when we want to attach these devices to animals, we can't get the animals back and charge the device back and redeploy. That's not actually something we can do. So realistically, we need a device that's going to be small and compact, but also log for the full amount of time. Also, if you put your phone out into outside or attach it to a goat and the goat went off throughout the Alps and you had it bounding over the hills, knocking this device left, right, and center, and then also you had the weather conditions constantly, you had weather conditions either with a changing temperature and constant rainfall could really mess up your device. So we need to make these devices really durable. That's where our magnificent technician comes in, Phil Hopkins. He designs these housings. We give him a problem that we have because we want to tag this animal, and he manages to produce these housings or these shells to protect the devices. I've actually got one here. So this isn't actually to do with my work, but this is the sort of housing they use on a penguin, or they think they've used this on sharks as well. And it keeps the device nicely protected inside. It can't be penetrated by water. And also Phil's given it quite like a low profile. So there's significantly less drag than say just a box. Cool. The next part of what I wanted to talk about was what can this data actually do? What questions can it answer? It's all very fun and everything, collecting this swish data in such high resolution. So it's worth noting that these devices collect sub-second. Now, sub-second is just a fancy word for more times than a second. So for acceleration, you can set the device to collect 40 data points per second to give you a really high resolution data plot. But sorry, where was it? But this is all good, collecting such vast amounts of data, but what questions can this actually answer? And I'm just going to try and tell that story to you by going through what I've personally done during my academic process. So for my master's, I studied Aldabra tortoise on Round Island, which was an islet off the mainland of Mauritius. It was this really cool, fantastic island, which not many people get to go to. So I felt very privileged. And we were studying the tortoise on this island. These tortoise were placed on the island as an ecological proxy. Now, that's just a fancy word for a replacement species, because the old mascarene or Mauritian species had gone extinct, and they've tried to replace them with a similar species. Now, the role for the tags were to understand why these tortoise weren't distributing themselves or weren't accessing the whole island. Why weren't they spread across the whole island? They were densely placed in a couple of areas in the island. So we placed these devices on them to give us an understanding of what might be driving their movement. For example, locomotion capacity, which is just a fancy word for the ability of the animal to actually get to places. For example, was the topography, or was the hills, was the weird different terrain actually inhibiting the animals so they couldn't move to certain locations? Was it food driving them? So they had a particular food they liked, so would stay in that area. And my project was there to set it up, and it's still ongoing. And we just scratched the surface of that, and we kind of made the understanding that we need to collect more data on this. And also, it's likely that the island hadn't reached full capacity, because historic documents had claimed that the islands used to be completely jam-packed for the tortoise. And realistically, you need a larger population to get them to distribute across the whole island, as there was no real competition there. So it was quite fun, really, because you get these tortoise and you pick them up, and they have these like grooves in their shell, so they're perfect to pick up. And you place them on a pedestal, and they're just placed on this pedestal where it would hold their carapace above the ground, so they couldn't get any traction. So they were just left like this, suspended in the air, and then we could apply the tag when necessary. And to try and keep the invasive method as minimal as possible to collect the device, which we needed to do to collect the data, we made it so that it was attached to almost like zip ties. So I just clipped them off, and I wouldn't have to put them on the pedestal for a second time. And that became quite interesting, because you had to capture the tortoises like without trying to stress them out at all. And people have laughed at me this a lot, but the tortoises was underrated fast. They were quite quick to catch, especially the small ones. And I don't know where this myth of the tortoise and the hare has come from, because these little buggers were quite quick at times. So it's sometimes I really struggle with that. And then I'd come to like check on them each day to make sure the device was still working and logging, so they'd get a sense of who I was. So if they saw me in the distance, they'd absolutely bolt it. So actually retrieving the tags seemed a bit tricky at times. There was also very large ones, so they weighed up to like 60 kilos, the sample I collected off of, and that when they're big, they can be quite strong. So I had this one big individual I was trying to collect the device of, and I managed to reach around, clip off the daily diary I wanted to take off, but then he just couldn't move one way. There's only one way he could come at me, because he was stuck against some palms, and he just went for me, and he just literally trampled me. And when a tortoise wants to go in a certain direction, he just goes for it. And I had to get my torso and my head out of the way, and he absolutely dominated me. It's a very strange feeling, getting completely dominated by another species, especially when it's a species considered quite passive and slow. So where are we for time? Okay, cool. After I did my tortoise stuff, I went to Valencia, and I went to a really cool aquarium called Oceanographique. I'd definitely recommend going if you're ever in Valencia or even Spain. And I worked with a project called ARCA, and they take in turtles as bycatch, and we use the daily diary data as almost like a welfare tool. And this project's ongoing with another PhD student at the moment, and it's a really nice novel method of using all of this high resolution data you're collecting to kind of get an idea of how this data can show the condition of the animal. This kind of brings me to my PhD work, which I'm working on at the moment. And at the moment, I work on alpine ungulates. Ungulates are just a fancy word for hooved animals. And the idea is to tag a range of species. And I've been successful in tagging domestic species, including sheep, goat, and cow. And I've also tagged wild species. You have wild ibex, which are like goats on steroids. They have the notorious big horns curving out of their heads. I have mouflon, which are effectively wild sheep, and then chamois, which is almost like a goat deer hybrid, and they're really they have a really great locomotion capacity. They can just spring and sprint across the mountains with minimal effort. The idea of tagging these species was to see how the species might be interacting with one another, especially separating the domestic and the wild, because the Alps are used as almost like free-range grazing during the summer months. When it gets warmer, the farmers are enticed to move their cattle up to the highlands and graze on certain vegetation. So we're using all this technology to find out when they're grazing and where they might be grazing, and see if there's any sort of competition overlap, to see if domestic livestock could be affecting wild populations. Not to mention, grazing itself is a really sort of fresh topic, in the sense that it has possible environmental implications. Now, that's not, I guess that opens up a debate in itself, but that's not strictly true. It's when grazing is really poorly managed, because the Alps opens up an interesting case study, in the sense that where they've stopped doing grazing within the Alps more and more over time, you actually have this reduction in a really key habitat for connectivity and species richness. So that's just to give you an idea that grazing isn't always the worst thing, it's just how it's managed. So the way these wild ungulates are caught is pretty extravagant. I work with a great research team out in France, and I was lucky enough to go out there to see them deploy my collars with my daily diaries and some GPS location collars on there as well. And the way they do it is they have this sort of like capture set up, where they all go up in the mountains, spend some time in the mountains, and they look at these traps which they have set up. And these traps are literally something from Scooby-Doo. They have a salt lick at the bottom and then a net on the top. I went like something straight out, like something Fred would have designed himself. And when the ibex or chamois come up to the salt lick, they then drop the net on them. The idea is that these ungulates are always seeking out salt. It's a really valuable resource to them, so they can be easily baited in using salt. And when they start to lick the salt, they literally pull out something from a spy movie with a big button on it, and click the button, and the net drops down. And then as soon as the net drops down from where they can see it, which is quite far away because they don't want to disturb the animal, literally sprint across the mountain as fast as they can, because they want to get to the animal as quick as possible to reduce the time of stress when they're processing that animal. And yep, I had to do that with them. And these French researchers are quite good at orientating themselves and moving across the Alps. So I wasn't so good. So they all ran as quick as they could, and I tried to follow suit. But instead, I was falling over in rocks and hair holes and all sorts, and just falling like a sack of potatoes over and over again, to the point where one of the researchers had to stay back with me while the other researchers went to the capture site and started to process the animals. Cool, so that ties up my little talk. I hope I've given you a good idea of animal tagging, and I'm just going to address the questions now. So for kids watching, what animals are tagged and why? And I hate to use like a scapegoat answer here, but to be honest, it depends on what question you're asking. And I think it's becoming, but this does bring up an important point actually, is I work on a wild dog project at the moment, and they tag these animals, and wild dogs are really endangered species. And without being able to VHF tag them and locate the species, they would have no idea of the population numbers or what they're doing and where they're doing it. And they had a recent terrible disease outbreak amongst the population, and without the use of tags, they wouldn't have been able to locate the species and the animals and actually understand that disease outbreak. So they can be really important tools. How large are the batteries that power the tags, and how long do they last for before recharging? Once again, it's really dependent on your project, and this brings up an important point that you need to stick within a 3% weight rule. Is a general rule we use. So your tag needs to be within 3%, but there's lots of ways to get around battery life. So you can reduce your sample frequency, you can reduce the amount of data, like different variables you're collecting. And also if you're collecting on a big species like an elephant or even a cow, weight's not going to be a big problem with the devices that you're using. So you can really, if you can get them weatherproof for that long period, you could go for a year or something really ambitious like that. But if you've got a small species like a bat, you need to keep the device really small, really light. So realistically, you're not going to be able to collect for a long time. I hope that answered that question. Question for from Instagram, what is the trickiest animal to tag? The trickiest animal to tag, I've not been involved in it, but I've heard people trying to tag jellyfish, which sounds really hard because obviously I think there's something stupid like 90% water. So I can imagine that'd be very hard. This kind of opens up that discussion with attachment methods. What's the best methods? Because a lot of people use collars, which are a very accepted method of tagging animals, but actually possibly ethically and for the quality of data, it might be best to actually glue the device on to the animal itself. Even though that sounds quite horrid, it's probably actually a better way of attaching the device itself. Sorry. I'm doing my PhD on Round Island Petrel. Any interesting in who else has been out? Yeah, I've been on, and the Round Island petrel is quite a unique species in the fact it's a weird hybrid species, and it's a fantastic place to work. And I don't know if you've been out there, but if you do get to go out there, I hope you really enjoy it. It's a very extreme environment to work in, and you need to be ultra cautious. But if you stay ultra cautious, you'll be safe and you'll have a great time. And it's a great at the moment we're all self-isolating, but that sort of isolation on that remote island is a quite unique experience. A question from Twitter: what are you working on at the moment? I'm still working on my ungulate species, but also I'm starting to become more and more involved in the wild dog project, where at the moment we're tagging individual in London Zoo to get some sort of baseline data before we start to deploy in the wild. What is your favorite animal that you've tagged? From Holly English. Favorite animal I've tagged? I did really like the tortoise. But there's something to be said for tagging domestic animals. When I first started, it was all about being really ambitious, tagging these really cryptic, exotic species. And I do still want to do that in many ways. There's something really great about doing my domestic goats and domestic cows because you get proper hands-on with the domestic species. You're literally there with the farmer, and the farmer will be like, there you go. They're all quite docile, so you can just get right amongst it and tag them yourself. And it gave me some valuable experience actually tagging domestic species rather than these wild extravagant ones. So I'd probably say the tortoise, because I got the experience of Round Island, but it's worth noting that these domestic species are really good fun to work on as well. Emily D, is the technology used in farming? So that's a really interesting question. The daily diary specifically isn't used for farming, but accelerometry, which I tried to describe earlier, is used a lot with farmers because you can use these devices to check for diseases and improve the animal's welfare and check for lameness. And there's some commercial companies out there developing these. I think they're not collars. They tend to attach the device onto their leg. But yeah, they are used within farming. And another question from Emily D: what about monitoring domestic animals? Well, I kind of answered that with the previous thing. So yeah, they do use accelerometry to monitor animal welfare, and but these are more commercial companies, and you don't get the high detail you do that our devices do, but they're still really useful devices. Okay, cool. So if that's all the questions, I think I'm finished. Just to say again, once again, thanks to Lizzie Daly for setting these live lessons up, and keep your eyes peeled for more episodes. I watched the episode previously about sharks. It was really good fun, really good, and really informative, and in my opinion, not just for kids. So I'm going to sign out. Thanks for watching. Bye.